My name is and I'm the Director of Sales for HM Royal Incorporated. Thank you for investing part of your day with us by attending today's online seminar. Our goal with this series of seminars is to introduce our customers to application experts from our supplier partners and engage in an exchange of relevant information to help you meet the challenges of today's demanding performance and regulatory environment. I'm a member of the WebEx technology that allows us to connect with each of you throughout the U.S. This technology does have limitations, though, and we realize that the best technology cannot replace a face-to-face exchange. Unfortunately, with the large group attending today's meeting, we are unable to hold a live question and answer session. Please put your question in the meeting center or feel free to contact our sales team for additional information. The contact information for our team can be found at www.hmroyal.com. Thanks for your time, and we hope that you find today's presentation relevant and helpful. I am pleased to introduce Gina Butak, Technical Development Manager with AkzoNobel.
Hello, this is Gina Butuk. I am the Technical Development Manager for Cross-Linking Applications and Polymer Additives. And today's talk is going to be on our line of Ketjenblack Conductive Carbon Black products. Start my discussion with a brief introduction of AkzoNobel, who we are, a company that has more than 350 years of history and cutting-edge innovation. You're probably familiar with AkzoNobel mostly for the paints and coatings lines of products. These two divisions are about two-thirds of, they form about two-thirds of AkzoNobel. Polymer additives and organic peroxide are part of specialty chemicals, which is our subdivision. In terms of some statistic numbers, as of last year, we have almost $15 billion in revenue and close to 50,000 employees worldwide, more than 200 production sites in more than 80 countries. We are a proud manufacturer of chemicals in the U.S. We make organic peroxide and polymer additives still in the U.S. Of core principles, we hold safety at very high esteem, and also integrity and sustainability. AkzoNobel had been recognized by Dow Jones Sustainability Index, and last year we came in first place. Some core principles. Customer focus, we work one-on-one to identify customers' needs and deliver on commitments. We have a passion for excellence, and we like to be winning together with our customers and collaborators. Okay, going back to Ketjenblack, the superconductive carbon black that can turn a then insulator plastic into a conductive product, as showing in this picture, which can actually conduct electricity. So this line of product of Ketjenblack, we have two grades. We have Ketjenblack EC-300J and Ketjenblack EC-600JD. Both these products are made by a process that's called gasification, and we control this product's purity by using a extraordinary pure raw material, and which is coal tar, and this is the raw material from which Ketjenblack products are made. This product, Ketjenblack EC-300J and Ketjenblack EC-600JD, come in a plastic bag. Ketjenblack EC-300J is packaged in 10 kilos in a bag, and EC-600JD is actually 8 kilos in the polyethylene bag. We recommend that the product will be dispersed into the end compound by opening the bag and have the Ketjenblack free-flowing into the mixer, whichever the mixing equipment it is, and by tossing the bag entirely in the mixer, as there's a vent on each bag that is a mix of various polymers for ensuring breathability of the bag. For people that can use larger volume of Ketjenblack for various large applications, we also offer these products in bags, or we call them super sacks. And Ketjenblack EC-300J comes in 200 kilos, while Ketjenblack EC-600JD is packaged at 160 kilos in the bag. And these super sacks will have a discharge port at the bottom, which is set on top of the mixing equipment, and the material will free flow into the equipment, into the mixing equipment. Ketjenblack Physical Form, as very well known, Ketjenblack is going to be a fine particulate and can be extremely dusty. And the way we control this dustiness is by turning it into a pelletized product. And the front pellets, they have a low crush strength. They are about 2 to 3 millimeters in size, and by doing that, we not only prevent the dusting, but we ensure that the product is readily mixable in the polymer matrix by ensuring a better wettability of the product. Continue with the physical form of Ketjenblack products. Under scan electron microscopy, this is a picture taken under scanning electron microscopy. It shows the type of agglomerates that are formed, starting with the primary aggregate, which is the pellet, which is about 2 to 3 millimeters in size, and then broken down into various agglomerates and aggregates, down to a basic carbon particle, which is about 30 nanometer in diameter. So it's a very, very fine particle. And I'm going to go into details later why this very fine particle has unique properties. Try to explain the morphology of the Ketjenblack. This is essentially an amorphous product. It is not a crystalline product with both large surface area and large pore volume. Surface area, we measure this by nitrogen, and also as indicated, the pore volume is also reported on the certificate of analysis. The structure is the articulates are almost like eggshell, hollow eggshell, so it's like half of an eggshell, and the primary aggregates has a particular great affinity for each other, which plays an important role in conductivity. Principles of various Ketjenblack. This is a side-by-side comparison. As I mentioned previously, surface area of the Ketjenblack line is high, as well as pore volume. By comparison with some more common type of carbon black, acetylene blacks, and furnace blacks that would have a similar pore volume as Ketjenblack EC-300, but much lower surface. The surface of Ketjenblack is about 800 square meter per gram, and Ketjenblack EC-600JD is about 1,300, so it is almost twice as large as the 300 series. So that is the quintessential difference between the two of them. They both have much higher surface and much higher pore volume than other commercial blacks. And Ketjenblack EC-300J is actually one of the largest surface area carbon black and high pore volume carbon black as well. Principle. If you remember from the picture showed before, that the amorphous structure that will be grabbing onto each other individual carbon particulates. So in order to conduct electricity, those particulates have to be either in touch of each other or at a very small distance. Therefore, the so-called electron tunneling, the electron jumping from one particulate to another, is facilitated. If they are at further distance, then the electron cannot from one particulate to another, so therefore the electricity cannot flow through. Needless to say that in order for a polymeric compound containing Ketjenblack product to be conductive or to have an anti-static property, dispersion will be the key. So, kind of summarizing, Ketjenblack can turn a plastic compound into either fully conductive compound or anti-static, just conducting electricity on the surface, and that depends on the concentration of the Ketjenblack as well as how well the product is dispersed in the final product. In order to the so-called percolation threshold, which is the lowest carbon black, Ketjenblack concentration, the end product becomes conductive. As indicated on the y-axis, we measure conductivity versus the concentration. Usually, the Ketjenblack requires a fairly low concentration, somewhere between 3 to 5%. And the first zone, the insulating zone, is also indicated in the picture above. When the carbon black is not dispersed, we have those pellets that are isolated in polymer matrix. They cannot reach each other, so therefore the electron cannot move around. As soon as the percolation threshold concentration is reached and the conductivity starts increasing, some of these carbon black networks are in direct contact with each other or close enough that can ensure the electrons jump, so therefore electricity flow. And this increasing conductivity goes exponential. So as soon as they start connected, the circuit is essentially established. And we reach the full conductive zone, which is the third zone in the graph, when a vast majority of those carbon black networks are in direct contact or close enough that they can ensure full conductivity over a three-dimensional network in the conductive zone. I will have a few slides in the follow-up where I indicate some concentrations, but in general, the polymer network, the type of polymer, the morphology of the polymer, the type of other additives present in the end compound, as well as processing conditions and temperature are all playing an important role in achieving full conductivity of the product. Slight comparison. In this case, we measure resistivity, which is the opposite of conductivity. Obviously, as resistivity drops, conductivity increase based on loading. In this case, we're talking about per rubber. So As I alluded earlier, Ketjenblack has a slightly lower conductivity, having a lower surface and lower pore volume than Ketjenblack EC-300J. But the conductivity, once we start connecting those carbon particulates, the conductivity is increasing exponential. And usually, for both these products, is way below 10 pHr. By comparison with other products on the market, you can tell in this picture that there is a huge gap in terms of concentrations. Some superconductive furnace black actually starts at about 20%, which is about 3 times as high concentration as the Ketjenblack product line. Specification of Ketjenblack EC-300J, we have a number of quality control tests that we run, and all these products are reported on the certificate of analysis in terms of surface and moisture content, volatility, density, bulk density, pH, very important, fines, grit, and ash. The fines are one of the lowest that you will encounter in terms of this kind of conductive black. For us, maximum is about 7%. That means 93% of the product is going to be in a pelletized form. Grits are extremely low. Ash is 0.05% being maximum. On average, actually, it is 0.01. The last column indicating the CPK, and as you can tell, the value is very small. So that means it's a very tight control process. They're saying that ash is very small, which makes both these products suitable for application where purity of the carbon black is very important. Applications such as electronics and high voltage wire and cable are highly sought after, and they actually are using a benefit from using Ketjenblack product. The specifications for Ketjenblack EC-300J are again very similar, except for the first two that are indicating the surface and pore volume. The same very low moisture, which keeps the integrity of the pellets until they have to be dispersed into the polymer matrix, as well as low volatility. And just like Ketjenblack EC-300, again, we have a very low grit and ash content, which can ensure that the products are used in applications where the high purity is required. So other impurities, the reason why the ash content is such low levels, or because the heavy metal and other metal content impurities are present at a very low level in each of these products. As you can tell, we test for nickel, vanadium, chromium, aluminum, cobalt, iron, copper, manganese, sulfur. Just to the few, we actually have a longer list. These numbers are not reported in the certificate of analysis of Ketjenblack product line, but we conduct a periodic analysis and issue reports on the impurity content. And we actually control this, as I mentioned at the beginning of the presentation, by the raw material that is used for the producing Ketjenblack, as well as by processing. And Most of these heavy metals like chromium is below the limit of detection of the 1 ppm, so they're extremely, extremely low concentration of impurities. Ketjenblack can be used in virtually with any polymer blend, whether it is a thermoset application or a thermoplastic or an engineered polymer or plastic, or even with elastomers. So regardless of the polymer structure, whether they are more polar versus polar, there's going to be a better affinity with more polar polymer, just because the Ketjenblack is slightly polar. But in essence, it can be dispersed in any kind of a polymer matrix. As end products or end markets in which Ketjenblack find use is packaging, particularly for the applications where the static dissipation is required, such as electronics. Wire and cable, again, this product line finds use in high and medium voltage wire and cable application. The automotive industry for various parts that require static dissipation or thermal dissipation, being flooring and carpeting, shielding of electronic components. We are finding increased in rechargeable batteries due to its large conductivity, and active polymers for electrostatic spray coatings. So a growing market. I mentioned earlier that dispersion is key in get the right conductivity, optimizing conductivity in a plastic or some polymer matrix compound. And we recommend maximizing dispersion but minimizing distortion. What that means is that that morphology of the Ketjenblack being those hollow shells, these primary aggregates can actually be sheared down and broken down by mixing process. This graph here is more of a qualitative indication. With this, we just want to increase awareness that there is a maximum or an optimum level of mixing that will ensure full dispersion before the particulates are sheared down and they might up losing some of the conductivity. They're not going to lose everything completely, but it's going to be diminished properties. In terms of mixing, ideally we'll recommend a twin screw extruder, but in essence, any internal mixer can actually ensure dispersion Ketjenblack in a polymer matrix. Time using some processing aids if that's necessary. Don't recommend single screw extruder. Probably will generate the least shear, and one pass to the extruder will probably not be sufficient to ensure a good dispersion of the Ketjenblack. Next, I'm going to get into a few examples using various polymer matrix. Those are just indicators and are examples that we worked in our R&D lab just to have a little bit of guidance when it comes to the concentration of Ketjenblack. But the type of polymer and the type of crystallinity or amorphous structure will actually play an impact, a role here. On this graph, we're measuring resistivity, and so therefore drop in resistivity is indicating an increase in conductivity. And we have a comparison of Ketjenblack 300J and the Ketjenblack EC-300J in HDPE, both compression molding and injection molding. So as you can tell from this graph, there is a little bit of difference whether there is a compression molding process or injection molding. Everything else stays the same. It is the exact same concentration of Ketjenblack, the exact same polymer matrix, and no other additives. But injection molding can induce orientation not only of the polymer chain but also of the particulate aggregates. So in the same time, the compression molding is actually freezing everything in place. So there is a slight difference in terms of measure resistivity and conductivity. Similar example, time in LDPE density. Again, comparison of 300 Ketjenblack EC-300J, both compression molded and injection molded, as well as Ketjenblack EC-600JD, also compression molded and injection molded. In this case, we have few data points, starting at about 3% with Ketjenblack EC-600JD and about 5% with Ketjenblack EC-300J. And the data looks a bit scattered, is only because it was those are lab samples. So in theory, it should be a bit smoother. This again is just to indicate where the conductivity or resistivity is going to be. And as you can tell, at 3% and at 5% Ketjenblack EC-300, the 600 is at 3%. The products are fully conductive. The resistivity is going to be 10 to the power of 3 and 10 to the power of 5, which are in essence fully conductive compounds. Ketjenblack main poly inlon 6,6 at concentrations of less than 5% for the 600 and less than 7% for 300. It's ensuring full conductivity. In this case, the polymer matrix is slightly more polar. So again, I can use slightly less additive for full conductivity. They can be mixed in readily. An example, Ketjenblack in polypropylene. This one is going to be slightly more crystalline, and in the same time, it's just going to be slightly more non-polar than the previous example. It's going to be for the Ketjenblack EC-600. By comparison, previous slide was at 3%. In this case, we have a 5%. So please bear in mind that the morphology of the polymer matrix plays an important role, and we're not even started mentioning the other additives contribution to the conductivity or resistivity. This example here is a thermoset application that is using 35% glass fiber. So and using a unsaturated resin at low levels of 0.5%, the compound is almost fully conductive, despite the fact that the glass fiber is actually an insulator in the polymer matrix. But the synergistic effect between the unsaturation, residual unsaturation of the polymer matrix and the Ketjenblack which actually draws the level of Ketjenblack at much lower level. Next example, in silicone rubber, in this case it is an elastomer, and again we are seeing fairly low levels of Ketjenblack for turning a silicone rubber into a fully conductive product, and both are compression molded. An example that I want to show is Ketjenblack in EVA with about 20% V content. And in this case, both these products side-by-side comparison in compression molding, they are showing extremely good conductivity at levels of additive being way below 10%. Factors that are influencing, some of the factors that are influencing conductivity, since talking about elastomer compounds, a lot of time they're going to be sort of a load applied to elastomer, whether it is tension or compression. In this case, we're showing tension. So as the integration increases, the resistivity increases, which is actually quite a logical phenomenon, since the distance between the Ketjenblack particulates are increasing, so therefore making the electron conductivity going lower. This is just a temporary phenomenon. As soon as the stress ceases, the conductivity is going to go back to the original. So in cases where the elastomer is going to be used in tension, a formulator will need to keep this in mind and accommodate probably with a slightly higher load of Ketjenblack in order to keep the activity intact over a longer elongation in terms of percentage-wise. I mentioned earlier that dispersion being the key, and the equipment that is recommended for Ketjenblack will be twin screw extruder. Another way for ensuring a good dispersion is by using dispersants, some sort of processing aid. We do recommend, we carry Armowax W440, which is super dispersant, is a polymeric ester that is used in conjunction with Ketjenblack. The example that I have here is 10% Ketjenblack EC-300J in polypropylene. Same mixing conditions. The control will have a fairly high resistivity. The other compound that will have about 2% of the processing aid added, the resistivity is much lower, therefore the conductivity goes up. And both products, both polymer matrices were mixed the exact same way. The only difference is that one contains the processing aid, which can assure a better dispersibility. But it's not the only dispersant. There are many others that can work with Ketjenblack. Ketjenblack EC-300J and EC-600JD are unique in terms of structure, and they have perfect use for making any polymer antistatic or electrically conductive. They have a low percolation threshold, low ash, low metal grit, and grit overall, which make them ideal candidates for use in high-performance applications such as high-voltage cables, semiconductors, and the automotive industry. We've been producing this product line for quite a while, so we have a reliable supply of these two products, and they're always produced as a consistent product quality. Thank you. That was my presentation.
Thank you, Gina, and thanks again to our attendees. I hope you found Gina's presentation helpful. This format does not allow us to hold a live Q&A session. If you would like to discuss the details of your specific application, please contact your HM Royal sales representative. This whole slide includes contact information for both Gina and me. Let us know if we can be of further assistance. Thanks for investing your time to learn more about AkzoNobel Ketjenblack Superconductive Carbon Black.